So hello everyone. So I'll be talking about Frost, especially with Zcash today. I gave a similar presentation at ZCon, but that's more high level. So I want in this call to be talking about more about the details and the technical details, is particularly stuff that we are not sure about. Because just to give you an overview, we have implementation of Frost, the library, but to actually deploy it, to actually make wallets use it, there's some things involved that we'll discuss shortly. So these are the things that we are unsure about, and we would love to have feedback from the community, particularly from wallet developers. So I'll get started by explaining quickly about Frost. So Frost is a threshold signature scheme, and it's kind of related to multi-sigs. I think a lot of people must have heard about those. But the goal here is to, instead of just having a single key that a single person has that signs things, in the context of the cache, the signing procedure is what actually makes you authorize a transaction, actually makes you able to spend Zcash. So instead of having a single key, you have multiple shares of the same key. In a way that as long as there's a threshold of participants, each of those has a share, they can get together and sign a transaction, for example. So Frost allows you to have a threshold T and split into n shares and have a threshold of T. So for example, we have a 2 out of a 3 wallet, for example, where 3 participants have a share of the key, but you only need 2 participants to authorize a transaction. This has multiple applications. I will talk about some of those shortly. And one main aspect of Frost is that the signature that's produced is kind of undistinguishable from a regular signature. So we don't have to change the Zcash protocol to use this, right? Because when you sign a transaction using Frost, looks exactly the same from the point of view of the protocol. It looks exactly the same as a regular signature. So this is also good for privacy because you don't even know that a threshold signature scheme was used, right? Bitcoin has a similar, the original Bitcoin protocol has a similar mechanism, but you can see, you see you have to put multiple signatures in the transaction when people can see that happen. So Frost is different in that sense. And one main thing is that you don't naturally need to create a key and split into shares. You can actually create the key already in split form. This is called distributed key generation. And this is great because at no point in the process of the key creation process, the key is present in memory. So that's good for security, right? So even if a single participant is, their PC is compromised, an attacker will be able to compromise, won't be able to create a signature because they will need a threshold of participants, not a single one. Of course, assuming T is larger than one. Okay, so yeah, create a key, you can sign with Frost, but there are also some additional operations that are supported. You can recover a lost share. So you, for example, have a Frost share in your phone, you lose your phone, then you can, a threshold of other participants can help you recover your share. You can issue new shares if you're managing some funds and a new person comes in to help manage this. You can add them. You can refresh the shares, which is something useful to prevent, to mitigate compromises, right? Every time you refresh the shares, if there's an attacker trying to hack the participants, they will have to start over again. And you can also change the threshold. This is something new that has come up in the literature recently. But these two last things our implementation doesn't support yet, just to make it clear. But it's technically possible to implement. So some Frost use cases, I think I have 2 scenarios in mind, which probably are the most useful. The first one is kind of a shared custody service, right? Because currently either you take care of our funds, which is good because you have control, but it's bad because it's people have a hard time keeping their device secure. Um, and on the other side, you can rely on some custody service that holds the key for you, which is good because they have more experience, making things more secure. But they still can get hacked or they can get bankrupt or whatever. So this is kind of a compromise. You can, for example, the scenario that I just an example. You have a share in your phone. You have a share in a shared this shared custody service, and a share that's backup in your own cloud, and using 2 out of 3 frosts. So if you want to sign a transaction, you open your wallet, you create your signature share, then your wallet will talk to this shared custody service. They will sign, they create a signature share, and then with these 2 signature shares, you can create the final signature and send the transaction. If the custody service gets hacked or goes bankrupt, you can restore your wallet from your cloud, or if your phone is lost, you can restore it from your cloud or from the shared custody service. So there are multiple ways to restore things if things go wrong, and this adds more resiliency and more security for people's wallets. Another scenario which I think would be popular is a group of people want to manage some funds, for example, an organization or something like that. So in this scenario, we have five people that want to get together and using a threshold of 3. So every time to authorize a transaction, we need 3 persons to sign a transaction. Then you can use distributed key generation. Makes sense in this scenario because we don't trust any specific person to generate the key and split it. So you can just generate it already split, and everyone can use a smartphone or PC or wherever. And if anyone loses shares, they can use the recover share functionality to recover the share, or you can just issue a new share. Um, cool. Uh, so those are 2 scenarios that we have in mind. If you have any other scenario that you think for us would be useful, please let us know, which we are interested in. It's good to have in mind what are the applications of Frost so we can better develop it. So I'll now briefly explain how Frost works. So one thing to have in mind that there are different roles, but these roles don't have to be different persons. So to make it clear, we have a coordinator. The coordinator is responsible for selecting the message to be signed, selecting the participants that will do the signing, and also to after everyone generates the signature shares, the coordinator aggregates these and produces the final signature. And the participant is the one that actually receives the message, signs, produces the signature share, and sends back to the coordinator. So any participant can act as a coordinator, and it's even possible to not have a single coordinator. Everyone can act as coordinator, and you can do a protocol to make sense that everything compare the different outputs from each coordinator, and to have a single output at the end. So I'll talk briefly about each operation. So trusted dealer key generation is one type of key generation where we have a dealer that generates the key and splits it into multiple secret shares that are sent to each participant. And each participant, when it receives it, validates it by calling this trying to function and creates a key package, which has the share of the secret. And also the dealer produces this public key package that the participants will also get. In DKG, it's a bit more complex because there's no single coordinator. So here I'm showing, just to be clear, this distributed key generation, right? So I'm showing this one single participant here, but there are a bunch of others, right? So the participant calls this DKG part 1 that generates a bunch of random packages, which they need to send to all the other participants, right? And they will receive the package from the other participants, and with their own secret package, they call the part two, which again produces a bunch of packages that are sent to all the other participants. So receive a bunch of packages back, and you call part three, and finally you get your own key package and the public key package, which is the same for all participants. Um, there are some requirements for the communications, and I'll talk about that soon. So for signing, you have the coordinator and multiple participants. Like I mentioned, the coordinator can be a participant. So the coordinator chooses a message, and each participant generates a bunch of signing commitments, which are sent to the coordinator. They create the signing package, which is sent to each participant, and each participant with the signing package, the signing nonce that was produced here in their own key package. They call this run to sign, which creates a signature share. So all participants send their signature shares to the coordinator. With along the signing package and the public key package, they call aggregate and produce the final signature. So it's a two-round protocol because here you have a one round of communication, and here's the second round because you send a message and get some message back. That's a separate round. So Frost is a two-round protocol, which is cool because a lot of other options had three rounds, and makes it simpler to deploy. There are also other schemes that are two-round, but Frost is one of them, and also allows you to pre-compute the first round if necessary. You don't need to wait for for the message to be chosen for the participant to send their commitments. As an optimization, you could just participant could send another 10 commitments to the coordinator, and the coordinator could use those do the other signings which only one round. But that's just optimization. So this is Frost, right? But I want to talk about Frost with Zcash. So to use Frost with Zcash, it needs to be changed a little bit, and the reason for that is that Zcash uses re-randomized signatures, which basically mean that each signature that's produced is produced under a randomized public key. And the reason for that is to, if you always use the same public key, then anyone looking at the blockchain could tell that, oh, this bunch of transactions were all signed by the same person. So you need to randomize the public key in each signing. And so we randomized Frost. Luckily, that's not difficult to do, and it's being specified in ZIP 312, which is ongoing. The ZIP itself mostly done, but Chelsea worked on a security proof for it, which is being reviewed. So we're waiting for that before we proceed with the ZIP review. But it's mostly done. And the only difference between Frost and re-randomized Frost is that it requires the coordinator to choose a randomizer in round two, and this randomizer is sent to the participants, which they use to randomize their secret share. In aggregate, you also need this randomizer to randomize the public key. Otherwise, it's the same as Frost. So same number of rounds, overall same complexity, it's just this randomizer that needs to be sent. So one particular tricky thing that I like to discuss is, how you do Zcash key generation with Frost, because Zcash has a bunch of keys, right? It's a kind of a key tree. So here I'm showing both sapling and orchard key trees. I'll mostly focus on orchard here. So we have this spending key, which is derived from the seed phrase, right? So we have a 12-word seed phrase. There's an algorithm that transforms it into a spending key, which is a bunch of bytes, basically. From the spending key, you generated this ASK, which is a spend authorizing key. And this is the thing that's actually signed the transaction. So this is the thing that we want to use Frost. But you also need other stuff. So from ASK, you derive this full viewing key. And the viewing key allows people to decrypt transactions, right? And if it's a full viewing key, you derive the outgoing viewing key, incoming viewing key, diversifying, etc., etc. All the stuff that Zcash requires. So okay, we want to use Frost, so we should just take ASK and split with Frost, right? We can do that, but if you want to use DKG, we can do that because when you use DKG, you can choose the key, right? You generate a random one, and you can control it. So at first, this would prevent us from using Frost with cache, but that's not true because this derivation, deriving ASK from SK, is not mandated by the protocol. Well, there's nothing in the protocol that checks if this was done or not, which is good. So we don't need to derive to do this derivation. We can generate a fresh ASK using the KG, right? And the Zk is just a public key, right? So this is also generated during the KG, and you can go forward with the key derivation, right? But let leave us a question of, you know, if people want to use Frost with cache, they also need the full viewing key, right? So each participant will need the Frost share and the full viewing key, which seems okay. Um, For saplings, it's trickier because you also need this proof authorizing key. So yeah, uh, so to use Frost with sapling, you need your Frost key share, but also either the proof authorizing key, the autogoing key, or you still should derive it from SK without doing this part, but doing all the rest. In Archer, the same thing. If you want, you could also derive it from SK. Bypassing this part. So that's a lot of information. I understand. So the question here is just, is it okay for people to require people to store just a full union key in a share and not use sapling, or if you want to support sapling, it's okay for people to store a proof authorized key, outgoing key, right? It starts to make it more complex because people are use it to deriving everything from a seed phrase, right? But in Frost, it will be a bit more complex than that. And also, there's this question: if you use trusted dealer key generation, I think you also do not want to derive from the spanning key. Again, to prevent people, having a seed phrase, and the seed phrase would allow you to recover the original key, which is kind of not the intention with Frost, right? So I think in both cases, you should not derive ASK from SK. And this also requires some API changes, which are not complex, but you need to be able to deriving a full view key, not just from SK, not just from a spanning key, but from AK, right? A public key from Frost and ephemeral spanning key that can be thrown away. So that's one part of the issues we face. Another part is, how do you store this? How do you backup this? Right? It's easier to backup a seed phrase. It's harder to backup identifier, a signing share, a verify key, and a full viewing key in the case of Archer, and a proof authorizing key in the case of Sapling. So yeah, this is something that we'll need to think about. Maybe encode it as a file and encrypt it with a key, password, right? Encode it to a big seed phrase. I'm not sure if that's will be a huge seed phrase, but maybe that's an option. Should we keep using the seed phrase together with AK? With that, you can derive the rest of the key tree, but there's still a bit more information that people are used to store. And if you do that, how you derive it, because how do you differentiate from a regular frost seed, a regular Zcash seed from a frost Zcash seed? Or maybe should we back up at all? Should we not care about this and just rely on share recovery to, if someone loses the shares, just the other people in the group can help them recover the share? So maybe that's another option. So I'll leave you to think about this with us. And the second big challenge is communications, right? You need to send messages back and forth between participants, and it's not obvious how to do this. Sorry, I just saw a question here. Uh, yeah, SK is not a seed phrase, but it's derived from the seed phrase, from the seed itself. I just talking about it like they were the same thing, because I don't know, from the point of view of the user, they just care about the seed phrase. Sorry if it is made my explanation confusing, but yeah, the question here is: do we still use the seed phrase and derive the rest, but together with an AK, or forget about seed phrases and just use the full win key, the case of Orchard, or the proof authorizing key, you have to go win key. Yeah, the original seed would be needed in case of a network upgrade is required to generate additional elements, a new payment protocol. That's a great point that I haven't thought about. Um, yeah, yeah, we need to. I need to think about this, but that's a great point. I'll think about this. Uh, yeah, I think Blanca just said use share recovery, and that's a very legitimate solution, I think. So maybe probably the first step would do just rely on this, and maybe in the future we can do something more complex. Okay, getting back to communication. So wallets don't talk to each other, right? Wallets just talk to the Light Wallet server. So how we get wallets to talk to each other? Um, and just to be clear, you need for this for the KG, you need this for signing, right? And recover share, all of those operations need communications. In a scenario like the shared custody I show you, you can use TLS. That probably solves the problem. But in a scenario like B, where you have just a bunch of wallets, then how do you do that? And also, Frost requires you to authenticate the channel for the DKG, and also to encrypt it in the scenario of Zcash, because the transaction is private, right? You can just send it in the clear. So yeah, we need, in this particular scenario, we need authenticated encryption channel, and that requires public keys and managing contacts. You have to have some mechanisms to register. Oh, here's Alice, and here's her public key. Here's Bob, and here's his public key. So wallets will need this kind of annoying but contact management thing to bootstrap secure communications. Um, and maybe there's some workarounds like copy and paste blobs, but I don't know. It seems bad for UX, but maybe that's a first step in getting Frost deployed. Um, what if you can verify Memo's message with payment addresses? That's a great question. We could do that, but I think it may be confusing for users because they basically have two wallets, right? The regular Zcash wallet and the Frost wallet. And they will need to use Frost wallet, they will need to use the regular wallet to communicate using memos. It's doable, but I think from the UX point of view, it could be difficult. I don't know. Um, um, sorry, let me get back to another question. In terms of storing secrets to restore without share recovery, does nothing prevent you from storing ASK share and K and either K as mnemonic phrase. That's the big seed phrase I suggested. Maybe that's a cool option. I didn't think too deeply about how big the seed phrase will look like. in how you differentiate it between a regular Zcash seed phrase and a frosted seed phrase, but it's a it seems like a perfectly valid possibility to look into. Um, the DKG setting can users' shares be derived from the seed phrase? No, I don't think so. Because the way the DKG works, Chelsea,
Not in the way that we've defined it. I guess the question's a little strange, right? Because in a DKG, the whole point, sorry to cutting
no,
throughout it.
go ahead, go ahead.
Yeah, the whole point in a DKG is that no one party can derive the secret themselves. So I feel like in that setting, you don't really want a seed phrase that any one person knows. But you could imagine a deterministic DKG, and that's something, if that's desirable, we can talk about it. But yeah, I think that's
Right,
something we should revisit as like maybe a deterministic DKG is desirable, but that's a slightly different question, I think.
right. Yeah, just the current DKG that we have implemented is the one which is in the Frost paper. The way it works, basically, each person generates like a multiple shares, and they, with some communication back and forth, they combine their shares, like a shares of shares, right? So the current DKG, we couldn't make that work because it's not deterministic, right? Each participant's shares depend on all the others participant shares. But maybe there's, like Chelsea mentioned, there's some other way to do that. Um, Chris said, having both regular and Frost wallets work together seems sensible to me. I don't want all of my transactions to be Frost encumbered. Yeah, that's a good point. Um, Nate said, I'm so curious about different UX approaches. One brainstorm. Use has a single wallet with a single backup phrase. They can participate in zero more Frost groups. Somehow those are distinguished in wallets. Then there's some way to review proposed Frost transactions, which a user can sign or not. Uh, that's not the way that I was imagining, but it seems to make sense. So maybe we can explore this somehow. I just wonder, like, yeah, yeah, maybe we can expose to this to underlying there will be two keys, right? Your regular key and your Frost key. But maybe there's some way to expose this to user in a simple way that they don't need to know about this. Um, yeah, basic trade is sufficient to bootstrap to get info from node to self memos. That's a good point. Um, Another brainstorm. There's just specified fast wallets where each instance is initialized to some group. Yeah, I'll just talk about that soon. Yeah, keep discussing, but so I'll go over with this part. So communications, we need mechanisms to wallets to send message back and forth, right? So I'm viewing this problem like there are two layers to this. The first layer is actually send a message, right? And this is like a networking problem. There's nothing to do with trust or cryptography. Uh, there's stuff like use turn, stun to bypass, firewalls, right? If you have something purely peer-to-peer, but maybe we can rely on some server to, some chat server to send messages, to help send messages. Uh, Maybe we could we could use something like Discord or Keybase to send this. I just had this idea. I don't know if that makes sense. The good thing about Keybase is that we already have, participant public keys, so it will be great too because I already bootstrap the crypto part. But yeah, that's something that I look into WebRTC, libp2p. And that's something that I don't know. I have no idea what's the simplest option, so feedback is very welcome here. The layer two is actually, adding authentication and encryption to the communications. It will be good if you have some solution that already does this, right? But if it doesn't, we can come up with something, right? It's if you're a cryptographer, it's not. I mean, it's not simple, but it's not super hard to do this. The annoying part, like I mentioned, making users, register public keys from other peers, that can be annoying. And layer three is broadcast channel. I didn't talk about this very specifically, but the broadcast channel is a whole thing, right? It's not just sending a message to everyone. It's a protocol that needs to be implemented, and this protocol needs to be used in DKG in order for the DKG to be secure. Just a way to send a message to everyone and make sure that everyone got that same message. Uh, if we have the other two layers in place, we can implement this echo broadcast protocol, which is not complex. So I don't think that's something that we need to worry about that much at this point. So the question I have, I don't know what wallet developers expect to solve this. Maybe a library that can be written and then wallets can call it. And this wallet needs to be Rust. Do people have opinions about that? There's and Dan showed me there's a thing called Hypercore, which would be useful to solve this. It's a peer-to-peer protocol, but in JavaScript. So I have no idea if that's usable for wallets. Um, okay, so that's the communication part. So this is something that I want to talk about. How it works in practice, right? I think for wallets is very would be very similar to offline signing. So this is something that Y Wallet supports. For example, you have two wallets, right? On one wallet, just have a Fulvium key, doesn't have the spending key. So this online wallet can create a transaction plan, right? Oh, I need to send this much of Zach to this address, right? It creates a transaction plan. The transaction plan can be transported to an offline wallet, which has a spending key, and this offline signs the transaction, and you go back to the online wallet and broadcast it. Frost would be very similar. The workflow would be very similar. You would have like a coordinator wallet. The tricky thing is that not full. In the case of Archer, you only need the Fulvium key, but for sapling, you need additional. I forgot the name of the key, but you need some additional stuff. But you create a transaction plan, right? But you need to generate the ZK proof because Frost doesn't care about that. You send this transaction plan, the Zcash, and the randomizer to the other wallets, and the other wallets only have the share, the Frost share, and all the information derived from that, and they sign the transaction, they generate a signature share, and this coordinator wallet aggregates them and broadcasts it. So having this ability to generate a transaction plan and to broadcast externally signed transaction, I think is will be key to make Frost work. So this already works with Y Wallet, but I think if I'm not mistaken, the other wallets doesn't support this workflow. So I think this like will be a first step into doing this. So we had a Frost demo. It's too much time to actually run it. Sorry if you're looking forward to that, but we did do this at ZCon, and Jones also recorded a demonstration. So you have this boat. Jones is a bit slower paced because at ZCon we had a limited time, so you can watch that to have to see how it works in practice, right? And there's also a tutorial, right? I'll go briefly go over how it works. I won't run it, but just to people have a sense of how it works. I created this command line tool with Y wallet code that can generate a Fulvium key, right, from a given public key. And the public key was generated with this other command line tool that just use you can run trusted dealer or DKG, and will generate a public key package, and this public key package has a public key which you input here, and you will show get you an orchard address and a unified full viewing key, right? So I got this full viewing key, and here in my wallet, you can simply import it, right? You can restore and just paste the full viewing key here. It's not here, but just paste the full viewing key here, and you create. I won't do this now, but I already did this for this wallet. So here's a wallet that is just a viewing key wallet, right? I can spend from it. But if I try to spend it, right, so just put some address, some amount. If you try to send it, it will show you the transaction plan. And if you click send, it will actually prompt you I'm not sure if it's been shared, prompt you to save this somewhere. This is a transaction plan, right, a JSON file. So this tool, you run the signing part of the tool, and will generate the ZK proof, generate a randomizer, and show you the SIG hash of the transaction. And then you can run Frost, right? You do all that Frost thing as I explained it before, where the message is the SIG hash and also the randomizer. So the coordinator generates a signing package. The signing package is sent to all participants. Each participant produces a signature share. You go back here, you go back to the coordinator. They will generate the final signature, and this final signature you input here, and you finally have the signed transaction, right? Then now you can go to Y Wallet and click broadcast, and if you select the transaction signed, it broadcasts. It's yeah, it's going to expire soon because I created this a few hours ago, but it works. Um, so yeah, that's it, right? You can use Frost right now with this demo we use it. Of course, I'll command line, but we are able to do this because Y Wallet supports offline signing. So if other wallets want to do it, the first step, like I mentioned, is having something similar. So yeah, this is how I envision the solution right now. You know, each person that wants to use Frost, they will have not maybe an account into their wallet that is a viewing key only, and they use that to generate Frost signed transactions. Um, so just to be sure, right? I split into coordinator and share wallets, but they could be the same wallet, right? Just whoever wants to start the process will be the coordinator. But you will need a full viewing key mode, right, for the wallet. Um, just to emphasize, transparent keys are not supported because Frost only works with Schnorr signatures, and transparent uses ECDSA unless we integrate Taproot, but I don't think that will happen. I don't know. Like I mentioned, sapling wallets are more cumbersome, so maybe the way forward is just to support Orchard at first. Uh, and the last challenge is, choose Frost. Each person is an identifier, which is a number. We added in our library a process to derive the identifier from an arbitrary string. So I think the solution here is just use your usernames or email address or something to derive the identifier. So I think that's not a huge problem, but we need to come up with a standard for this. I'll go back to the question shortly, but just to finish this, here are some user stories that wallets will need to support. So the first part is setting up communications, and that will depend on whatever the specific communication solution that is chosen. But we probably need some mechanisms to generate a public key for yourself, send to other people, and read other people's public keys, right? And then create a new DKG wallet. So each participant will in their wallet menu, they create a new DKG wallet. They will choose the other participants and they run the DKG protocol, and they will get a new account, which will be a Frost account. Uh, Another user story would be to create a trusted dealer wallet or join a trusted dealer wallet. Uh, so whoever creates will generate a bunch of key shares. They need to send somehow to the other participants, and the other participants will import this and set up their Frost wallets. The main story is, of course, in sending Zach, and will be like I showed you in my wallet. The coordinator will generate a transaction plan. Transaction plan needs to be sent to the other participants. The other participants will, they need to be shown the transaction plan, so they consent to it, generate the signature share, send back to the coordinator, and broadcast the transaction. And additional shards will be backup if we need one, repair someone's share, refresh everyone's shares, or maybe if for some reason don't want to use Frost anymore. If you have a threshold of people agreeing with this, you can unfrostify your wallet and get a regular Zcash wallet back. Okay, so let me get back to the chat. Yeah, there's a bunch of ideas. I don't think I can. I really need. This is a bunch of interesting discussion. I hope this gets saved somehow. But yeah, let me check if there's some question that's not super hard to answer.
I can start bringing folks up
Yeah,
as panelists as well.
That sounds good. That sounds good. Yeah.
Oh, okay.
Sorry, just to jump in to kind of help guide discussion a little bit. So as Conrado said, the most important thing the foundation can get out of this discussion is input from wallet developers about what they need in order to integrate Frost into wallets. So I think there's a lot of interesting discussion here, but the most important thing we can understand is basically from wallet developers, what are their plans to integrate Frost and what are the challenges to doing so, and how, like, what do we need to do? What do we need to build or design or anything to help move that process forward? So kind of to help, guide those next steps.
Yeah, sorry. I had this slide that I forgot about. We have related to this. We have some questions, right? Which are there any other use cases that people are interested? Any deployments of Frost that we're not aware of? What do you think about those Frost key derivations? I think this is what we're discussing in the chat. Related to backup shares, should we specify a format? Should we not just rely on recover shares? And about communications, any restrictions about language? Is it okay to assume users will be online? I think this is an important question because it will change it will impact the solution, right? It's okay for to require that people are now online at the same time to sign, or maybe one person signs today and other person signs in 2 days, and that will require some message box server or whatever. How to set up bootstrapped communications, what type of infrastructure will be okay for wallets to use. If you need a central server for do this, it will be this okay. If one wants to collaborate on getting this deployed. But go ahead if anyone wants to chime in.
So maybe I can add a couple points here. There's a lot of open questions, right?
Yeah.
And the way I look at this is really we need to figure out the user experience, what we want to deliver. Maybe start with specific use cases, like you started with suggesting a simple backup mechanism, user's device plus a cloud backup plus maybe a third party infrastructure service provider. And then maybe move on to something like a social recovery or other use cases, because we are not the first ones, I mean, to make a multi-sig delivery here. It's more
Yeah.
like it's fielded and there's many more improvements. So we can learn from other implementations out there, like the, what's that, Gnosis Safe, right? So they have done really good job, maybe starting from how they have implemented. But my comment over here specifically was around, like, at least to play around with these new signing schemes. Can we have like a centralized place where we could use these signature schemes, like the Libra Zcash? That is in Rust, correct?
Yeah, yeah. Just to be clear, we have a library that does Frost, right? But it's like it doesn't handle communication or anything like that. It just does the crypto part of it in the Zrust, right? Maybe we could start integrating. I'm not sure if it would make sense to integrate with Rust Cache. I have to think about it, but maybe that's an option. Yes.
The Orchard Builder is structured in a way where you can it separates out the process of like making the bundle and the proofs and applying signatures. So
Cool.
and it does, I believe, there's an API for just applying a signature to a bundle that you've generated elsewhere, which I think we added in collaboration, like in order to enable the Trezor use case. I think the way that they wanted to do things, so it should be entirely possible to take the transaction builder that at least the transaction builder at the Orchard level. I don't know about the Libra Zcash crates in their current state, but the Orchard builder should be able to be integrated in that way.
Yeah, I used this in the demo.
The Orchard builder is in the same crate as the rest of the Orchard crate.
Right. Yeah, we used this in the demo. It works.
Yeah.
But there probably some. I need to look into it a bit more, but this part, applying a signature works, right? But I think maybe the randomizer generator, I can't remember exactly, but I think it kind of generates the randomizer on the fly, which is okay, but I'm not sure it would be like, the way it works is sorry, I'm trying to formulate the phrase here. Is that I'm not sure if the randomizer generator is totally separate from the other part, but I need to look into this.
Taco?
Yeah. Hey, yeah, this is great. I agree with Addy's idea to start with the most basic stuff. I don't know if someone is transcribing the call in writing or someone is writing really fast. So mute because it's distracting me.
Yeah, sorry.
Cool, great. So I was saying, yeah, I think that since there's a lot of complexity in the, you have the UX part, the technical part, maybe focusing on like polishing out, I don't know, the use case that we think it's the most useful in the short term would be a good idea. I really like the first case, which is like the person having this threshold scheme for backing up and signing transactions and having alternatives to avoid disaster. It's really interesting, but it doesn't like need much communication than like yourself, I guess. But you need to implement like how to back up the shares and it could be a simple use case to just focus on like backupping the shares and how to store them in a format that makes sense to just regular people, and then just move on more complex things. I don't know. I think that I will take it from there. Like, just try to do the simplest thing first, and then like expand over like orgs. Except like there's a pressing use case that it's super needed and super like has a lot of like it would bring a lot of value, or there are like other parties that are pretty important to the ecosystem that needs that like or stuff. I would just start from the simplest, which is like user shared custody service or something like that.
Yeah, the tricky thing about this one is that the shared custody service is kind of non-trivial to implement, and depending on the idea, it will serve multiple users, right? So they will holding a bunch of shares from different people, and they need to be secured. Of course, if this gets hacked, it's not catastrophic if they had the whole key, but it's still bad, right? So we still don't want that to happen. So writing the service and make it secure, it's non-trivial, right? The second scenario is it has its complexity, but I think you just need a wallet, right? Just need wallets to talk to each other, and you don't need a special service to do this. So
Oh,
yeah,
great.
I had in mind that the first scenario would be the first thing to do, but I got convinced that the second scenario I think will be a better first step.
Yeah, that makes sense. Yeah, whatever is the simplest, I think it's better. Cool. Awesome.
So we have some hands up. Try to go in order here. Zuko.
Dang, it's hard to hit that unmute button. Did I get it?
Yep.
I'd also like to echo Adi's comment that starting with use case is a good idea. And I'd like to add that if you can find a willing user, that's even more useful for guiding you. And I've heard this call for wallets as potential users. So that's a good start if we get any willing wallets. And I want to offer another candidate, which is BitGo. They're a very important company in the whole crypto ecosystem. They're longstanding supporters of Zcash. And as I vaguely understand it, their entire product line is all about that 2 out of 3 custody use case that you mentioned. So if you could get in touch with them and ask them to evaluate whether they would use Frost for their products, that might be really informative.
Yeah, that's a good point. I looked briefly into it to see how it works. There's a very specific architecture, so I'm not sure how flexible would be for them to decide to adopt Frost, but it's worth looking into. Yeah.
Okay, let's see here. Nate.
Well, I just lowered my hand, but I was basically going to say that I'm excited about the use case of like DAOs. So the 305 organization, there's a group that controls some funds. That seems like it could be fruitful for a few cases already in the Zcash ecosystem. So just plus oneing that.
Yeah,
Absolutely.
I agree.
Strad.
Trying to remember what my hand was up for. Yeah, the for the scenarios here, the like obviously we can do any combination of these that we want, whether they involve a cloud service or not. Like if you go to 3 or 5, then it's feasibly possible in future for one of those 5 to be a cloud like a backup organization, but most of the time you don't have to interact with them at all, which could be handy. And I think there are some existing companies that do that kind of thing. I noted in the chat, but I wondered if any either wallet devs or ZF people had thoughts on the like the resharing process, like the process of cycling the shares and the effect that in terms of UX on I mentioned in the chat briefly, but like on the effect on the fact that full viewing key has to rotate, so the effect on scanning and addresses and whatnot. Like is the UX fun, I guess, associated with that commensurate with the benefits of supporting share rotation?
Yeah, one thing about this, when you this refresh share capability doesn't change the group public key, so it won't change the address of the
Okay, so
wallet.
refreshing doesn't change it, but
Yeah.
issuing a new share presumably does.
No,
That doesn't either.
no. It's magic.
Oh, okay. That I had missed in the DKG somewhere. Oh, that makes things much nicer.
Yeah. Of course, it's still tricky because you need to, when you refresh people's shares, you need to be sure that everyone actually refreshes shares, because if one didn't, then someone did, then chaos will happen.
So
So
it's a N of N to do the full refresh then when
yes,
yep, okay.
yes, that's true.
So it's not a so, and then for issuing it'll be N minus one of N,
Yeah.
but that does give you retain the same public key.
Yeah, if someone doesn't refresh the shares, they won't be able to participate anymore. Yeah.
Oh, nice.
I think so. I could be wrong, but yeah, I think so.
All right, let's see. Hazel.
So I think my first question was already answered, which was if share recovery had to be T of N with the same T as signing, or if it could be configured separately. You said that it's N minus
Yeah.
1 of N?
No, to recover a lost share, you need T. You can, unfortunately, it's the same T as signing. It's fixed, yes.
Okay. And we at Zynga would definitely be interested in using the distributed key for our treasury instead of currently we're just like manually voting it and one of us is actually holding the key. But one thing I didn't understand is why the scenario A shared custody thing was more complex than the second scenario. Oh, because scenario A had trusted dealer keygen. Okay, I totally misunderstood scenario A when I read it the first time.
No, it's fine. But I think the main cause, you could use the KG. Yeah, you could use the KG here, but I think the main complexity is the shared custody service, right? I mean, it depends. I don't know. I may be overthinking it, but I think this piece of, it has to authenticate users to make sure, to know who are talking to them. So we have to authenticate users, have to manage shares securely. So it's
Okay,
certainly
so
non-trivial.
I'm gonna jump in really quickly. Do you mind going to the next scenario B? So I think what's not shown on this slide is you still need that coordinator role, right? So you still need some way that for messages to be passed among all of those users. So I think either way, right? I mean, unless you know some fully mesh system that I'm not aware of. You still need some way, like you need a PKI and you need users to know that they're talking to the person that they intend to and the messages get there and all that kind of stuff. So if you go back to scenario A, I think, yeah, I think regardless, there's going to be some infrastructure somewhere, right?
Yeah, I think in the DKG scenario, yeah, I think it's possible to do completely peer-to-peer, but it's, each person has to generate the public key pair, send
Right,
it to
but it's like you still need some kind of root of trust. So it's like I can generate a key and claim that I'm you.
no,
So it's like somewhere you need some PKI something. So I think
yeah, I
there's
was
a lot of
thinking,
complexity hidden in scenario B.
yeah, I was thinking we could do like checking fingerprints, like, right, to you send people, you need to actually, talk to the other person to make sure, check the fingerprint to see if the public key you have is actually their public key, right? So I think that's one possible way to avoid having a PKI, but still annoying from user experiences.
Dodger, did you want to chime in? I saw you raise your hand and posted something in the chat.
Yeah,
Yeah,
like verifying.
yeah. Just to comment on the last thing, when I want to make sure that I'm talking to when someone's signal number changes, or signal key changes, I get an alert, and if it's a really sensitive conversation, then I might call them up and say, hey, I want to check that this new Signal account is really you, and you can do it in video, and Signal has a nice mechanism where you can do the hold up a QR code and whatnot. So I think it's a solvable problem. One thing I'm really interested in hearing from potential integrators is what you think of this whole communications requirement. There's two schools of thought within the foundation at the moment. There's one school that I'm part of, which says we need to have a solution for this. It should be a solution that anybody who implements Frost for Zcash should be able to use, so that you don't end up with walled gardens type situation, i.e., Nighthawk wallet users can only be part of a Frost group with other Nighthawk wallet users, and Zingo wallet users can only be part of a Frost group with other Zingo wallet users, and you can't have one person using Nighthawk and another person using Zingo to be part of the same Frost group. So that's one school of thought. The other school of thought is it doesn't matter. Wallets should build their own solution, and we don't need a universal or federated type of solution. I'm just interested in hearing what the potential integrators, wallet devs, and whatnot, what their view is on that.
Would anybody like to chime in on that? I don't see any hands, so I think what Dodger's talking about here we'll save for another chat, or we can do it asynchronously. Oh, we got some hands up. Here we go. Paco.
Yeah. Hey. Yeah, I think that something that will be really useful from a Zcash point of view is to try to have a common way of doing things. Also to not reinvent the wheel many times, and instead of it could be like a collaborative effort, or all teams can commit some resources to actually work on this, instead of just being one org doing the work and then the other ones waiting on it, as usually maybe has been happening over the last years on Libra Zcash stuff, for example. Could be interesting to use this really common case to try to put some other dynamics into works. So yeah, I agree with like the first take on like having something that everyone can use, maybe first as a reference, and also that just to put our resources more effectively there.
Nate?
I'll advocate for the other side. Well, not completely the other side. So I guess I was going to advocate for um, people building things that work as quickly as possible with less coordination, if and with sort of a prototyping mindset, and then after users have examples to play with, we can learn from that and then integrate. Um, I think that approach is a possibility. Maybe not, maybe coordinating together arrives at something useful across the ecosystem at the same time or not. I guess I'm just a fan of doing whatever enables users to start trying things earlier and then worrying about compatibility um, after the fact, as long as the users know to expect, as long as users know not to expect backwards compatibility. So, because the thinking is sometimes it's hard to coordinate everything up front and sort of make standards before you've made the applications, because that takes some amount of effort and may slow down deploying some applications. And then after you've done that, you might learn from seeing things in the wild that there were some mistaken assumptions in the coordination in the first place. And so it can slow down that learning process. So coordination is good, interoperability is good across the ecosystem, but also learning quickly from experimenting with real users who are consenting to that sort of thing is valuable. So some balance between those. So I'm also thinking of, for example, different changes or improvements to Light Wallet descamming. Like Y Wallet just came out with something, and then ETC worked on something, and then there may have been some other variants, and then over time we figured out, okay, now that we've seen these different things and learned from them, how can we integrate them? Yeah, it's just a brainstorm.
Eddie?
So ideally, I would have advocated for the second part, that is to keep the network protocol modular and open so it can be implemented separately. But seeing all the fragmentation we have right now in the Zcash ecosystem, wallets, addresses, unified addresses, liquidity servers, it's getting to a point where we cannot recommend someone something to try out. It's getting to that level. So at least to start with, if we can figure out the pros and cons of a protocol, which can be maybe P2P or existing key pair mechanism, you just maybe trusted, hate to use the word trusted, but which is utilized by a wide variety of users to do the key exchange and access, and then kind of recommending that, but still keeping the networking layer modular. So someone like BitGo can come and implement it their way into their private ecosystem to manage custody of their clients' assets. That's how I'm thinking.
All right, we have no other hands up. Does anybody have any comments or questions based on some of these most recent people who spoke? Or maybe anybody who posted something in the chat during the presentation that they'd like to bring up? All right. I'm not seeing any other hands. Any final closing thoughts, Conrado?
No, I think, thank you, the last speakers for the discussion about, the best way to do this. I agree. We need some kind of standard way to do it, but maybe like Matt suggested, maybe to do it and then make standard somehow. But yeah, I agree there's some tricky aspects to it. But yeah, I think it was really useful. I'll read the chat later. I already saved it. But yeah, what to do next? So we're not sure exactly what's the next steps. I think this call will help us define that. So we have this demo, right? We just command line tools, and they don't talk to each other. We need to copy and paste blobs between users, right? So maybe the next step is advancing on that, and maybe first or adding some graphic interface or adding some communication mechanism. I don't know exactly what. Just to try to build on top of it. I was discussing this with Natalie today. Maybe it doesn't need to be, it can be like a separate app for now, which can then later be integrated with wallets. I don't know. That's one possibility. So yeah, we'll think about this with this feedback that we had today. But yeah, if anyone else has anything that about this all these questions that we asked that we like to say to give an opinion about, please reach out to us. I'm not sure what's that you can open an issue in the Frost repo, or you can jump in the R&D Discord or whatever. You can reach out to us. It's fine. But yeah, basically we'll figure it in the next steps based on the discussion we had today, and let's see what happens. Yeah. And also think the light client working group, which happens every 2 weeks, will be a good place not to keep things right live and proceed in the discussion.
Absolutely. Eddie, I see your hand still up. Was that a new one? No? Okay. Cool. So yeah, please feel free to reach out at all the places Conrado just said. I'm thinking maybe I'll create a new Frost thread on the forum as well after I get this video posted, and we can communicate there as well. And then we'll chat internally about getting another one of these calls set up. And as Conrado said, this could be a topic in the Light Client Working Group as well. So with that said, this was recorded. As I mentioned, I will get this up on the ZF YouTube, probably create some shorter clips as well. And we can go from there. I appreciate everybody joining. This was a very great discussion. And thank you, Conrado, for walking us through everything. Appreciate everybody.
Yeah, thank you, Ron, for attending.